Orbital velocity you can write. Orbital velocity. I hope everybody can understand. Right. The velocity required for an object, the velocity required for an object to revolve around any planet, to revolve around any planet, to revolve around any planet in circular orbit, to revolve around any planet in circular orbit. In circular orbit is called orbital velocity, is called orbital velocity, is called orbital velocity. Orbital velocity, right? Expression for orbital velocity. Expression means what? Everybody. Expression means what? Formula. Expression for orbital velocity. Orbital velocity means, suppose if I want to rotate the satellite around the earth, so what is the velocity I have to give, Mitakshri? Anybody can tell me? Some velocity I have to give. So that velocity I have to calculate it or not? Yes, please. Yes or no?
Yes, sir.
Yeah, let us see. If I want to, suppose future you launch the satellite. So what is the orbital velocity you have to give to the satellite so that it will not fall to the earth or it will never go away from the earth? So expression for orbital velocity, remember, symbol is always will represent with the V naught. What is symbol for orbital velocity, Hari? V naught. Okay, so that is what? Formula is root of GR. What is the formula? V naught is equals to, what is the expression, Mitakshri? Root of G into R. Okay? Any doubt? Anybody? Hari? Kaushik?
No, sir.
That is. So, let us take. Now, is it orbital velocity depends on mass? That is what my question. Is it orbital velocity depends on mass? Yes or not? Yes, please. Does not depends on mass. Okay, so it will never depends on mass. Only planet will decide. So let us find orbital velocity for Earth. Orbital velocity of Earth. So if I want to launch a satellite, so what is the velocity of satellite I have to maintain to revolve around the Earth? So orbital velocity of Earth, if I'll take, okay, which is equals, this is the common formula, guys. Now you tell me, what is the G value of Earth and the radius of the Earth? You should tell me. G value of Earth, 9.8. Okay, into radius of Earth, fastly, 6.4 into 10 power 6. Is it necessary? Is it necessary, all of you? Yes or no? Nobody will say. Yes?
Yes, sir.
That is what. So do it now, multiplication, 9.8 into 6.4. How much it is? Which is equals to, how much? 62.72 into 10 power 6. So do it all of you. 10 power 6, you can take it as a 10 lakh. You multiply, you will get it. So into 10 lakh. 4560. So we'll get approximately 62, 72, 00, 00. Is it, everybody? Will you accept it? If this is what you will get. Yes or no, guys? Yes or no? Do it. Take your time. It doesn't matter. You have to take your time, and I want that only. All of you do that. Mitakshri, anything down, Mitakshri?
Yes, sir.
Have you solved this one? Okay. Now, let us come back now. root of this value you have to find. Root means approximately, suppose root 4. How I can do? Root 4 means I can say 4 means 2 square I can write. So square and root will get cancelled. So what is the root 4 answer? What is the root 4 value? Everybody.
2, sir.
Same way, if you'll do the root of this value, okay, so you'll get the answer. So the approximate value you'll get if you do the root of this one is 7,919.5. 7,919.5 meter per second. Okay, or I have to give 7.9 kilometer per second. This is what the orbital velocity of Earth. Understand, Mr. Harizeras? Arun Kailash, Akilan, Gokul, all of you. So this is what it will happen. So all should learn. This is how we people can do. So if you want, you can do the root of, I will say you. So clear everything and you can do root of, you can put 62, 72, 0, 000. I will send the values, guys. I will send the screenshot in our group. All of you check it. Root of I have done. If you have a calculator, you can see I have been done the root of that value. I will share with you. Is it right or wrong? Everybody verify. Can I send it now? Yes, all of you see that. I'll send the value in the root value of this one. So you'll get the value 7,919.5 meter per second. So which is approximately equals to how much? 7.9 kilometer per hour. So if I want to launch a satellite which will make to rotate around the earth. So what is the velocity I have to give everybody? What is the velocity I have to give the satellite? Harini, Harizeras, Arun Kailash. What is the velocity I have to give to the satellite? Everybody. I have to give the satellite 7 point, how much? 7.9 kilometer per second. That is what approximate value I have to give. Then only the satellite will revolve around the earth. So any satellite revolve around the earth, we have to give the same orbital velocity. So that is what is called as orbital velocity around the earth. So this is what the common formula for calculating orbital velocity for anything. For NTSC and all, it will be coming. It's very, very important. So please. So the derivations and all they will teach you. So now this is for foundation what we used to call what is orbital velocity. So orbital velocity means root of acceleration due to gravity into radius of the planet. That is what you have to remember. Okay, guys?
Sir?
Yes, sorry. Ask me. Okay?
Sir?
Ask me, Hari.
Sir, I got answer as 800 root 98, sir. If I solve means I'm also getting 7919 meter per second.
Very good. No issues, Hari. Your choice, Hari. No problem. Whatever you are getting, no issues. Okay? Your simplification send in group. Let them see others. Okay? Yes, Mitak.
Okay, sir.
Please respond.
Yes,
Nobody.
sir.
Next. Escape velocity. Let us see escape velocity. What is escape velocity? I told you. Harizeras, Arun Kailash, escape velocity. I told you what is escape velocity. Everybody. So the minimum velocity required to go out from the force of attraction. Is it yes or no? For example, if we'll take the Earth. So Earth will pull the every object with the acceleration due to gravity. How much it is? 9.8 meter per second square. So if I want to launch the rocket, so at what velocity I have to give? More than this or less than that? That is what my question. Yes, please. Everybody, I have to give the escape velocity more than this 9.8 meter per second square. Is it yes or no, guys? Nobody? Yes, that is what. So right. Definition. The velocity required for a body, escape velocity. The velocity required for a body The velocity required for a body to escape into space, to escape into space, to escape into space from Earth surface. From Earth surface. That is what the diagram also I have drawn. From Earth surface, bracket you can write earth gravity. Understand everybody? Earth gravity, earth surface or earth gravity is called is called is called is called is called escape velocity. Is it okay, Harry? Yes. So escape velocity, I will take it as a EP. Oh, sorry, EVE you can take. Escape velocity is what? Escape velocity of Earth. So no confusion. So let me take escape velocity is VS or V, whatever it is convenient. So you can take, I will take EVR, no need to confuse, or I can take EV. Escape velocity is equals to, because here also you will get confused. I have been done for Earth, so you can take it as Earth only. VO. VO means what, Amma? VO means orbital velocity, orbit. So orbital velocity. V means, yes, E means escape velocity is equals to root of 2 into G into R. That's all the formula. Understand everybody? What is the formula escape velocity? Root of 2 into G into R. Now, can I write this one as root 2 into root GR? Is it right or wrong? Everybody? Root 2 into root GR? Yes or no? Yes or no?
Yes, sir.
Yeah. Root GR is equals to something. Check it. What is that? Root GR is equals to
Orbital velocity.
orbital velocity. So I can say escape velocity from the surface of Earth is equals to root 2 into root GR, which is equals to what I can say, escape velocity, sorry, orbital velocity. That is what I can say. Orbital velocity. Is it right or wrong? Are you understanding? So escape velocity of a Earth is equals to root 2 into orbital velocity. So you'll get the escape velocity value. So let us find for escape velocity of Earth. Escape velocity of Earth. So tell me what is the answer? Root 2 into what is the orbital velocity of Earth? We calculated. What is the orbital velocity of Earth? All of you. Everybody should tell me. What is the orbital velocity?
7.9 kilometer per second, sir.
7.9 kilometer per second. That's all. So 7.9 kilometer per second. So if you will multiply this, do that. Root 2 value is, all of you remember, 1.414. So do that everybody. 1.414 into 7.9 kilometer per second. All of you do that multiplication and tell me. Mithakshri, what happened? Have you understand, Mithakshri? $1.414 into 7.9. How much will come, Hari? Arun Kailash, never answer. I will shout, but still I will never get any response. That is what the escape velocity from the Earth. How much? I said you already before also. How much we have to give? Approximately 11, understanding, 11 kilometer per second. This is what the escape velocity of the Earth. So if I want to launch any satellite from the Earth, so the rocket should travel 11 kilometers per 1 second. So then only it will escape. Otherwise, it will never, it is not possible to escape from the Earth. That is what you have to remember. Is it okay, guys? Yes, guys. That is what you have to make it. Okay, so all of you should practice it. This is what you can calculate for any planets. Remember these two formulas: escape velocity and orbital velocity. This is for all the planets. Very good, Akilan. Yeah, Akilan said in meter per second, 11,197 point. Yeah, 11,197.16. 11,000 11,196 something you will get approximately. So it's not 196. So you can take, I have taken a rounding off. So you can get 11,1706 point something will come. Meter per second you can take. So that is what. Okay, everybody? Yes, Hari? I think 11,170.6 will come. Yeah, zero point 0.6 will come. 0.6, not this, 0.6, 11,170.6 meter per second. That is what it is. That is what escape velocity of Earth. So this is what we can calculate. Whatever the planet, we can use these formulas for orbital velocity and as well as escape velocity. Hope everybody understand. So with that velocity, if you launch the satellite only, it will reach the orbit and then only it will revolve around the Earth. If not, it will be fall into the space or it will go away from the Earth. Is it okay, all of you? So answer Mr. Hari send in group. You can see how neatly he simplified. So you also all should learn the simplification method. Okay, everybody. So try to learn it and make it. This is all about the today's class, escape velocity and orbital velocity, as it is very, very important. So the next class, you can see same orbital velocity and satellite velocity. I will teach in another different set of formulas also. So whatever it is convenient, you can turn. So after that, we'll go to the second half of this chapter. That is only pressure and thrust. Is it okay, guys? So with this, I'll stop the today's class. So you all should learn till here everything clearly, whatever it is. Very, very important foundations. Gravitation is a major chapter for your higher classes. So, and even it's very tough. You might be feel the difficulty in calculations now itself. So concentrate so that you can do very well in the higher classes. Okay. So thank you all of you. Bye. We'll meet in the next class.